Today we're going to practice using sample spaces to find the difference between and or probabilities. Some of the problems that we use are going to give us all of the information that we need, while others of them have some additional steps that we're going to need to use before we can actually find the probability we need. Alright, our first problem says that our spinner has 11 equal areas numbered 1 through 11. We need to find the probability that with one spin we land on either a multiple of 2 or a multiple of 3. So for this one, the first thing we're going to do is draw out our sample space. Again, our sample space is just all of the possible outcomes listed out in front of us so that we can see them. So for this one, it's just going to be the numbers 1 through 11. Okay, so the first thing that I'm going to do is go through and I'm going to circle all of the possible multiples of 2. Next, I'm going to go through and I'm going to circle all the possible multiples of 3. Now to find the final probability, all I need to do is figure out how many different numbers I've circled and how many there were in all. So altogether I had 11 options, so my probability is going to be out of 11. And in total I have 1, 2, 3, 4, 5, 6, 7 of them circled. So my probability for this statement of multiples of 2 or multiples of 3 is going to be 7 out of 11. It's important to note on this that I did circle 6 twice, but I only count it as one possible outcome. For our second problem here, we now have a spinner that has 13 equal areas, and we're trying to find the probability that our spin is a multiple of 5 and a multiple of 2. So notice the difference between the and the or statement. So I'm going to make our sample spaces start. First I'm going to go through and I'm going to go ahead and circle the multiples of 5. Next, I'm going to circle all the multiples of 2. So as a reminder on this one, we're trying to find the probability that the number I land on is a multiple of both 5 and 2. So for this one, it turns out that 10 was our only option. That means that our probability for this one is going to be 1 out of 13. So for our third problem, we now are starting to get into a realm where we have not quite enough information to solve what we actually need. So we're going to have to do a little bit of work before we can find the probability. For this one it says, in a certain Algebra 2 class of 21 students, 10 of them are basketball players, 9 of them play baseball, and 8 students play neither sport. What's the probability that a student chosen randomly from the class plays both basketball and baseball? So right now I need basketball and baseball. However, I don't have that number given to me. And on top of that, if I take the numbers 10, 9, and 8 and I add them all together for all the students, that adds up to more than 21, which is a problem because there are only 21 students in this class. So for this problem, our sample space, we're going to use a table. I'm going to draw that real quick. Alright, so in our table, we've got on the left side in that column, we have basketball and non-basketball players. Across the top, we have baseball and non-baseball players. Now, I know that there needs to be a total of 21 students in all. So my goal is to make that final row and that final column both add to 21. I also know from here that 10 of them play basketball. So that means 10 people, regardless of if they play baseball or not, play basketball. So that 10 is going to go over here in the table. Okay, same thing with baseball. I have 9 baseball players. It doesn't matter if they play basketball or not. I've just got 9 of them. And then I also know that I have 8 students who don't play either. So where both of the X's match up, that's where I'm going to place my 8. From here, I'm now going to start filling in the table with the other things that I know. In the far right, I know that I need to have 10 plus something equals 21. That means I'm going to have an 11. Across the bottom, I know I have 9 plus something equals 21. That means that I'm going to have 12 there. From here, I'm going to go ahead and just fill in the rest of the table. In my non-baseball, I know I have a total of 12 now, so I have to have 4 that also play basketball but not baseball. Going across the top now for my basketball players, I need to have a total of 10. I already have 4, so I need 6 more. And going down that baseball column, I need a total of 9. I have 6 there. That means I need 3 more. Okay, so we've got this filled out. Now I can go ahead and go back to that question. The question was, what is the probability that a student chosen randomly from the class plays both baseball and basketball? Plays both of them. So the only spot on my table where they're playing both is right here, is this 6. And we've had a total of 21 students. That means that my final probability for this one is going to be 6 out of 21. Okay, for our last problem, we have the same kind of situation here, except now you'll notice that it says what's the probability that they play basketball or baseball. So in this one here, they just have to play one or the other. They could play both, it's fine. We just want to know what's the probability that they're going to play one or the other. So for this one, we're going to start off with that same table we did in the last problem. All right, so we're gonna set this up the same way. For this one, we have 23 total students. We have 7 of them that play basketball, so 7 total play basketball. We have 12 that play baseball, so we've got a 12 down here, and 9 that don't play either. Okay, now we're gonna start filling in those spots. I need 12 plus something to equal 23. That's gonna be 11. Now I need 7 plus something to equal 23. That's gonna be 16. Now we can start filling in the rest of our table. Going across in my non-basketball players, I have a total of 16 of them. I already know that 9 also don't play baseball. That means that there's going to be 7 that do play baseball. Going down that baseball column, I'm going to have to fill in a 5 there. And going down the non-baseball column, I'm going to have to fill in 2 additional players there. So for this one, our final question was, how many play basketball or baseball? So here they can play just basketball, they can play just baseball, they can play both. So I'm actually looking at this one, and this one here. I'm gonna add those all together. I have 7 plus 5, that's 12, plus 2 more is 14. So I have 14 out of a total of 23 students play at least basketball or baseball.